This network implements an oscillator. The input begins at 1, but when I run the network, it quickly goes to 0. Consequently, the dynamics that we observe are largely a product of the recurrent connections in the network. You'll notice that the architecture here is similar to that for a neural integrator, with an input driving a recurrent population. That's because both are examples of attractor networks. In this case, however, the A population is two-dimensional, and the recurrent connections are implementing a simple harmonic oscillator. This can be seen by looking at the decoded values of each of those dimensions. One traces out a sine curve, while the other traces out the complementary cosine curve. Unsurprisingly, when we plot this decoded value in state space, we see that it traces out a circle. Thus, we can think of the network as being dynamically stable, insofar as it will continue to trace out this attractor until there is a perturbation. We can also look at the network dynamics and single cells, noticing, for instance, that particular neurons are active during specific phases of the network oscillation. And finally, we can look at the pattern of activity laid out on a cortical sheet, seeing, for instance, something that looks approximately like a traveling wave during these kinds of dynamics.